We're testing antibiotic-resistant bacteria and its effects from the relative density of CAFO in the area. So we have previous literature posted on this topic, but that was more water-focused, and a lot of the stuff we're focusing on now is air quality-based. So we've tested it through the means of dust sites and bioaerosol. This poster specifically is trying out a new method as well, so there's kind of a lot of variables to figure out here. But what we're calling the overnight method is a lot quicker than our traditional multi-drug resistance pathways. Those kind of take a couple weeks that you have to do on a bunch of different cell cultures. This one hopefully can get you like next day or within three-day incubation results. So this is kind of the area we've sampled in Tulare County, and we were testing 3 different antibiotics this time, being our E, AMP, and P for penicillin.
We tried to collect bacteria from air and from dust. So for dust, we actually went out to gas stations and mailboxes in our preliminary tests, but for this poster, we mostly focused on gas stations. And what we would do was we would dip a swab into PBS, which is phosphate buffered saline, and then we would collect dust from an area like on a gas station where we would kind of identify a lot of dust had kind of accumulated over a period of time, and we would assume that like bacteria in the air would kind of be deposited there. What we did was we took these samples and we deposited them on 2 types of agar, nutrient agar and then Reasoner's 2A agar, which are both pretty non-selective. Na is the more non-selective out of the bunch. And on these agar plates, we also had, like Camille was saying, the different concentrations of antibiotic, 16 micrograms per milliliter of erythromycin, and then the corresponding for each antibiotic type and concentration. And so these are our 2 graphs for our results for resistance ratios on our Na plates and our R2A plates across our different sites. And we classify them as like UI for unimpacted, AI for agriculture impacted, LAI, which is kind of confusing, for less agriculture impacted, which just means like unimpacted would be our clean site, and then AI would be our kind of dirty site, like we know that's via CAFO, we know it's impacted, and less agriculture impacted in comparison is like a cleaner site that we know has some kind of contamination. And then our urban impacted sites was actually our college town, and we assume that it's kind of impacted because we had a big hospital presence, and so the resistance that we saw in the bacteria we are kind of attributing to the hospitals. So anyways, back to our results. So for our Na graph, we kind of saw a lot was going on with penicillin, and we're kind of unsure about what exactly our results mean, but we're assuming that our spikes for penicillin in the urban impacted areas can be attributed to the hospitals in our college town, but we're not like 100% certain. But we saw like pretty good trends, really small amount of resistance in our unimpacted sites, and then progressively like larger amounts of resistance in our agriculture impacted sites, and then similar patterns for R2A. Although the penicillin story is a little bit different. Here, the agriculture impacted sites dominated over urban impacted, which makes more sense to us. And then also ampicillin is kind of telling a weird story across both different types of agar, which we talk about later in our conclusion. And then this is our bioaerosol graph, and this actually tells a story that we kind of expected. TC was our dirtier site, and then SKC was our cleaner site, and it shows a pretty good story in terms of resistance ratios. So a lot higher antibiotic resistance was observed in our dirty site as compared to our clean site across all concentrations of antibiotics in our agar.
And yes, so as you can see from our graphs, we see like a lot of results from E, better results from E. So we've concluded that, or we've hinted at the at erythromycin being a good indicator for antibiotic resistance, especially for airborne particles. It should also be noted that erythromycin is one of the more common antibiotics that are used in humans and animals alike. We want to collect more samples from other CAFO impacted regions using E as an accurate indicator, just to also kind of reconfirm our results and kind of strengthen the foundation. And then we also want to collect samples from different urban sites because of our strange results from P, from NA, as we established already. It may have been caused by the hospital nearby. So we want to try different urban areas or more suburban areas as well. And then we also want to refine our agar selection and narrow down the most effective medium for monitoring. And in addition to this, we also want to integrate qPCR and more metagenomics to be able to characterize what bacteria that we have, to also better identify which types of agar to use.
Save the earth.